Good afternoon, class. So this video is inspired by Jess. Thank you so much for your comments and for your constructive feedback about how to do this video better. So I thought I'd do an update video on how to do the unit conversion problems numbers 1 through 24. So I thought I'd do my examples again, which would be number 1 and number 11. But this time what I did was I added some notes to show you where I actually got some of my updates or where I did my substitutions. So if you look back in the notes on both unit conversion numbers 1 through 10 and the second one, which is 11 through 24, you'll see a whole bunch of notes on the first page. On that first page, what you'll see is several things, and so the first part you'll find on derived units will be force. So force will be equal to a Newton, which will be equal to the letter N, which is equal to kilogram meters per second squared. Eventually, I think I stick in there a wording, word conversion for the unit, so it'll actually say kilograms divided by meters times meters per second squared. I actually wrote that out there. But I wanted to leave this part right here so you can see the substitution. Also, later on, I did some variable work for number 11, so that would be the velocity, with the units were meters per second, but as a variable, it was v. And time is seconds, and as a variable, this was t. The reason why this is important is because this number 11 is a two-step problem, sort of, and then number 1 is basically a plug and chug, substitute, and go. So let's look at number 1. It's newtons times seconds squared per kilogram. So what we do is we then say, okay, what is the seconds squared and kilograms are definitely base units. Can't do anything about that. However, this Newton is something that is a derived unit. So what I need to do is break it down into base units, which is where I get newtons equals kilograms times meters per second squared. So from there, I substitute from newtons to kilograms times meters per second squared. And hopefully you can see that contrast with the change of color. Once I've done that, what you'll notice is that I've got kilograms in the numerator, kilograms in the denominator. Second squared in the numerator, second squared in the denominator. So what am I going to do? I'm going to cancel them using my rule that anything divided by itself except 0 is 1. So we cancel out kilograms, we cancel out seconds squared, and we're left with meters as your answer. So then let's go to number 11. We've got velocity times time. What is that going to be? So what we do is we look at velocity and find out that as a variable it's v. So if we know that, we see v over here, we know that that's the variable, so we substitute what velocity is over here. So that's why velocity will be meters per second. So instead of v, I put meters per second. Time as a variable is t, which is this variable right here. So what I do is I then say, okay, time is equal to seconds. So I put seconds instead of time. Now that I've done that, I've got meters per second times seconds. So I can say, oh, I have meters per second, seconds in the numerator, seconds in the denominator. I can cancel the seconds, and all I'm left with is meters. So this would be how to do number 1 and number 11 on the unit conversion problems numbers 11 through 24. So again, thank you guys for your feedback. Please, if you have any other feedback for me to make these videos better, please let me know in the comments below so that I can improve these videos and give you a shout out at the same time. So hope this helps. Study hard. I'll see you in the next video.